Hi guys. Okay, so now we're doing 10-2. For those that took a break and didn't want to do the whole thing, we are back. All right, so now we're talking about a central angle. Makes sense, and if this gets cattywampus, I'm sorry. So here's a picture of an angle that intersects a circle in 2 points. And has a vertex at the center. So basically, they're talking about that angle. Sum of the central angles. So you know a circle is 360. So there you go. An arc is part of the outer edge. Okay. Now, this one here, I have arc measures in degrees because I get this confused. So arcs measure are in degrees. So that obviously minor meaning smaller arc. It is the same degree. So this would also be x degrees if you were talking about degrees, arc measure. The major would be the whole, well, on this one, does it say A, B, D? Okay. This whole thing here would be your major, so you would just subtract it out. So 360 minus this will give this amount. And then this last one is a semicircle, and you guys should know a semicircle is 180. Straight line, 180 degrees, semicircle. All right, don't confuse arc length with arc measure. So arc length will have a formula on next page. Okay. Hopefully you have your calculators out because we're going to need them. Okay. So, in the same circle or incongruent circles, 2 minor arcs are congruent if and only if their central angles are congruent. So, if this and this were congruent, that also means that this and this are congruent. Okay. Arc length. This is what I was talking about. And they've got a proportion equation or an equation. In the front of your packet, I prefer this one. Just FYI. So the arc length is different than the arc measure. So pay attention to that. All right. So given this down here, XZY. So XZY. WC is the radius. This is the major arc. It's minor arc or semicircle. Well, that's semicircle. Sometimes I wonder if these are trick questions. Let's solve, makes that straight line there. WC is your radius, right? WZX. So you've got to follow this as it goes. So it's W, Z to X going that way. That's going to be your major arc. And then XW, so just this little guy, it's going to be your minor. So far, so good. Next page. Okay, so we are going to find LHI. So LHI. Are we trying to find the measure? Not the length, the measure. This one here, since this side is 90 and this is 180, this side would be 90 as well. So that's 90 degrees. That's easy. Find I, J, K. IJK. So we have 180, because I've got semicircle here, right? And I just need to find this part. So I really could take my 180 and subtract that 32 to get 148 degrees. Okay. And now we're going to find the arc length. And I'm going to get rid of these. I don't want you to see any of these things. Pretend like they don't exist. We don't know these things. Okay? So, measure of HML. So this angle here is x plus 3. JMK, so this angle here is 2x minus 10. So remember, when they are like this, they are find HL. Okay, so now we want to find that arc. So now we're going to find the length. Is that right? If we have the length, try to find, there was something wrong with this equation. Oh, I think we're okay. Set both of these equal to each other. So we're going to go x plus 3 is equal to 2x minus 10. Subtract x, add 10, subtract x. So I get 13 is equal to x. So x equals 13. And so x plus 3 is 16. And that is the measure of HL, that arc. There you go. Yeah, that's right. I should have getting rid of those because that would totally mess you up. Okay, so now let's go back to the same thing. So HML we've got is x plus 2. And JMK is 3x minus 26. So get rid of those old ones. Find JK. So again, we set them equal to each other. Minus x, add 26, add 26. So that becomes, what is that? 28 is equal to 2x. X equals 14. Now JK, so that's what this means. JK arc is equal to 3 times 14 minus 26. So JK, punch that into my calculator. 3 times 14 minus 26, 16. As well. Perfect. Okay, so this one, they're trying to find arc length, which is different. Okay, so this is measure of the arc, which means that the angle and that measure of this arc are equal. Here, you're going to use that other formula. So I am going to, does this give me enough information? Each arc length. AC is the diameter. Okay, so let's go back to that formula. Arc length. L, I'll write it down here. L is equal to x degrees divided by 360 times 2 pi r. All right, so AB, because you have to have your radius, is 4.5. this is 40. So we have our x and we have our r. Now we just plug it into that formula. So our length is 40 divided by 360 times 2 pi r. Actually, that's all right, 2 pi, my radius is 4.5. So I'm going to simplify what's in the parentheses. 2 times 4.5, was it 9? 2 times 4.5, 9. So really what I'm saying is this times 9 times pi. So let's do it. 40 divided by 360 times 9 is 1. So this is just L is equal to pi. Just want to double check. Times 9. There it is. All right. This time, let me keep checking. I'm not moving my paper very well today. So, okay, so DC, we're looking for this. We're going to be looking for this side. Okay, so DC, how much is this angle? Wouldn't that just be 180, because it makes a straight line here, minus 40, gives me 140 degrees. Okay, same thing. A to C is 12, which means B to C, my radius is equal to 6. Okay, so let's keep going. Somebody wanted in my door and I don't want to stop. Okay, so my length, L is equal to my 140 divided by my 360 times 2 pi r, which is my radius, is 6. This is going to be a little easier. So 140 divided by 360 times 12 times pi. As you can see, I'm simplifying this. 140 divided by 360 times 12 equals 4.6, round to the nearest hundredth, 67 times pi. All right. What else do we have? I think that's it. That was pretty easy. All right. Happy assignment.